Hello, this is Mr. Stansbury taking you through one more example on the student's t-test. Okay, so next example, fat content in grams of 30 randomly selected pasties at the local bakery was recorded. All this raw data here for a mean fat content of pasties made at the bakery, mu, that mean. Conduct a two-tailed t-test of, where HO is the mean equals 16 grams on a 10% level of significance. So, step one, null hypothesis. So, HO is going to be that the mean fat content is 16 grams. So, basically what they're claiming. So, mean fat content is 16 grams. Okay, so that means the alternative hypothesis is that it's not 16 grams. Okay, mean fat content not 16 grams. State the significance level. They told us that it is 0.1, which is 10%. Okay, so down here, I'm going to make our little inequality. I know it says step 1, step 2, but I like to go to step 5. As soon as I get my information, 0.1, and then we'll figure out what our p-value is there. Okay, calculate the value of the test statistic. So t is going to equal, we'll figure that out when we put it all in our graphing calculator. And it even says right here, a two-tailed t-test, which would make sense because you're not sure if it's going to be higher or lower than 16 grams. So that's when you're not sure if it's going to be higher or lower, it's always going to be this one right here. Okay, so now what we want to do is get our graphing calculator out, and since we've got a bunch of raw data, whenever you have a bunch of raw data, you always want to go into stat and edit, because you're going to edit a list. So again, that's stat and then edit, and then you're going to edit your list. Now I went ahead of time and put all this data in the list here, all the way down to 30. You're just going to have to believe me because this will take a while to get down there. Okay, so once you get all your data in, we're going to do stat again, and instead of edit, we're going to go over to test, and we're going to go back over to our t-test, push enter, and then now we actually have the raw data, because it used to be in stats, which we had to enter all this stuff in, but now since we have the raw data, it's actually going to calculate some of that stuff for us. So the raw data, and then what we want to do is we want to go in and say, it even tells us the HO is 16 grams. So here's our mean, the null part of the mean. This here is going to be 16 grams. Okay, and then our list, we made our list in list 1. So we do frequency list is L1. If that's not already showing up for you, then you just do, let's see, where's L1 is right here. So you do second, and then number 1 would pull up the list 1 for you. Frequency is 1 because each one of those just represented one piece of data. We want to go into the not equals part. So make sure, especially if one of these others is already highlighted, make sure that when you go into this here, instead of it just blinking, you got to push enter so that it makes that one, nothing else is highlighted. And then go down to calculate, and it will come up with all of our important juicy information. So our T is negative 0.40. Okay. And then our p-value here is 0.691. 0.691 is our p-value. Okay. Now, is 0.691 less than or equal to 0.1? That is not true. Right? So it says reject HO if this is true. Since it's not true, we don't reject. We do not reject HO. Okay? So that means we actually accept it. We accept HO. And then back up here, HO is our mean fat content is 16 grams, okay? So basically, We cannot conclude that the mean fat content is significantly different from 16 grams is basically what they're getting at. It's a weird way to state stuff, I know, but we accept HO. Okay. So basically we say that the cannot conclude that the mean fat content is significantly different than 16 grams. Okay? Okay. That is the third t-test example there. So hopefully this t-test stuff will make a good amount of sense now. Okay? If you have any further questions, please feel free to ask. Thanks.